All right, so that in our previous segment, we mentioned that a planet goes around a star in an ellipse. And so that was the only kind of orbit that Johannes Kepler knew about. But Sir Isaac Newton was able to calculate two other kinds of orbits that an object could have. And so what he did was he compared the speed of, let's say, a rocket ship versus the amount of gravity that was trying to pull that rocket ship down onto a planet. And so it's kind of a competition between the speed, which wants to make the rocket escape, and then the gravity, which is trying to pull the rocket ship down. So we can compare the energy of the rocket ship because of its speed. So that would be its kinetic energy. And then we could calculate its potential energy caused by gravity. And so we're going to compare these two numbers, the energy caused by the speed and the energy caused by the gravity. And so if the gravity part is winning, so then that means that the potential energy is going to be larger than the kinetic energy. But notice that the potential energy is a negative number. So that means that if the potential energy is larger and you add it to the other number, you get a negative number. So if the total energy is a negative number, it cannot escape. And then it has the elliptical orbit, just like Johannes Kepler said. But if it has just the right speed, then the kinetic energy becomes stronger than the potential energy, and then it can't escape. And then that's going to be called a hyperbolic orbit. And then if the two of them are exactly the same, so if your speed is just right so that those two energies are the same, it still does escape. And we call that speed the escape speed. So that is the minimum speed necessary to be able to escape the gravity of a planet. So I don't want you don't have to calculate any of these energies, but I want you to just to be aware of the different kinds of orbits. So you have the hyperbolic. When it just barely escapes, that's going to be the parabolic orbit. And then if it can't escape, then that's going to be the elliptical orbit. And you should be able to tell me under what conditions will each of these different kinds of orbits occur. And so this one here shows how to actually calculate the escape speed. And then there's also another one, which is the speed that you would need to have in order to go in a circle around the planet. So don't worry about those two formulas. And I did provide a chart that shows different kinds of speeds that are necessary to escape. Okay, let's take a break, and when we come back, we will discuss relativity.